0.05 becomes minus 0.05 here. I'm not going to carry the a and the t minus 2t. And this bounces off as 0.2 of that. That means 1/5 of that. So it's a plus 0.01. And that comes here as 0.01. And a quarter of that means 0.0025.
Dr. Rihanna, if you want to find the voltage on the left side of the bounce diagram at 2t, would you add minus 0.2a or minus 0.05a?
You have to add both.
Okay.
Both of them coexist at that instant, at that location.
Okay. All right.
And these two also coexist at that instant, at that location.
Okay.
So what we do now is, I'm not interested in which one goes right and which one goes left, because I'm not doing the frequency mean where I want to find out positives and negatives in gamma frequency mean. I'm interested in a time domain waveform. So basically, I look at this signal, that signal at the ascending end. So at the ascending end, I'm going to make a table here. At 0, I see 0.375. At 1 nanosecond, that's nanoseconds, which is round trip of 2 times 0.5. I see additional minus 0.25 times 0.375. And right here I see additional at 2 nanoseconds. That's additional. 0.0125 times 0.375. And if I go here now to draw a signal as t, that's magnitude. So I do 0.375, lasting until 1 nanoseconds. That's nanoseconds. And then I drop by that much. Like that. Stop it. And then I come here and add that much. And then again drop some more. And then I'm going to add some more, and so on and so forth. It's going to be zigzagging, as you can see the polarity here, up and down, until I converge here. So that's your V ascending end of infinity, which is the final value. So these increments, this increment right here, is that much. And this increment right here is that much. The original, we do that in blue, is that much. Those numbers are this one ends up to be 2.8125. The next one is 2.859375, if you wish. You know, I got all the digits. Next one is 2.857031. And the final value is 2.857143. How to get the final value? We use the final value theorem, which is basically the DC solution for this as omega goes to 0, right? Or S is equal to 0 either way, if you are working with Laplace domain. And the DC solution would be simply a voltage value between this and that. That line here would be simply a wire connecting the two with no influence. So that is 10 times 50 divided by 50 plus 125. And if you do that, you end up with this number right there. 2.8 57143. All right. Now let me challenge you. There is something else that we can do in the remaining 6 minutes. Finding the voltage here will be similar, right? Let's find the voltage here, somewhere. I stick a meter in the middle. Let's say the middle, exactly the middle. Right? Find the waveform here. What's going to happen is these components are still separate here. They are not at the same location. So I'm going to see my 375 coming in later. So that's now 0.25 nanoseconds. I'm exactly in the middle. So a quarter of a nanosecond, I'll see the first 0.375. Then I go that far, half a nanosecond later, so that's 0.75 nanoseconds. I see the negative part. And that negative part happens to be 0.1875. I'm sorry, minus 0.75. Minus 0.75. Which is this one. Then I see the positive part, and that comes right there at 1.25 nanoseconds. I see that positive part. And that is, no, I'm sorry, that's also negative. That's negative. My apologies. That's further negative. And this one here is minus 0.1875. And it's time to see the positive here. It will be a positive, followed by another positive. Right? Well, hopefully this is on video recording that's going to be posted up, so you can go back and review it again. You see the result. And that also goes for the people that did not make it today. Whether they have an excuse or not, they will get the benefit, right? You guys want to punish them? We'll make this a secure video only. You can see it. Make copies and send it by email to everyone. All right. Any questions before we go? So we have a second midterm coming up on the 31st, right?